One small step, one giant leap of faith. The Apollo 11 landing. On July 20th, 1969, the world held its breath. Neil Armstrong piloted the lunar module Eagle towards the moon's surface. The Sea of Tranquility was their target. But the unknown lurked beneath the surface. Would the landing be smooth, or would they encounter unforeseen dangers? Armstrong's primary objective upon landing was collect lunar samples immediately. As the Eagle descended, Armstrong noticed the designated landing area was fraught with boulders. Fuel dwindled with every passing second. In a remarkable display of skill, Armstrong took manual control. Finally, the message crackled through the tense silence. "Houston, Tranquility Base here. The Eagle has landed." At 10:56 p.m. Eastern Time, humanity had achieved the impossible. Stepping onto the lunar surface, Armstrong uttered the now iconic words, "That's one small step for man, one giant leap for mankind." The fine, powdery dust clung to their boots, a constant reminder of the alien environment. It was unlike anything on Earth, electrically charged and incredibly abrasive. This lunar dust, as fine as flour, posed an unforeseen challenge. The Sea of Tranquility fortunately proved to be a stable landing site. Yet the lunar dust, clinging tenaciously to everything it touched, presented its own set of problems. Armstrong's quick thinking during the landing proved crucial to the mission's success. His decisive action, opting for a manual landing in a smoother area, demonstrated the importance of human intuition and adaptability. The Apollo 11 mission wasn't just about reaching the moon. It was about exploring this new world. Every speck of dust was a scientific treasure, meticulously collected and returned to Earth for analysis. Among the items returned from the moon, one carried particular significance: the lunar sample return bag used by Armstrong. Destined for the Smithsonian National Air and Space Museum, this unassuming bag held the very first lunar samples collected by human hands. Its journey back to Earth, however, took an unexpected turn. Due to a clerical error, the bag was mislabeled and ended up in a government surplus auction. In 2015, Nancy Lee Carlson, a lawyer from Illinois, purchased the bag for a mere $995, unaware of its true value. When she sent it to NASA for authentication, the agency realized its mistake. A legal battle ensued, with the government claiming ownership of the priceless artifact. The court ultimately ruled in Carlson's favor, recognizing her legal purchase. Section 4, Earthbound Astronauts, the rigorous training of Apollo 11. The success of the Apollo 11 mission rested on the shoulders of the astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins. Their journey to the moon began long before the launch, in the simulators and training grounds of NASA. In 1968, a year before the launch, the Apollo 11 crew embarked on a rigorous training regimen. Countless hours were spent in simulators, meticulously crafted to mimic every aspect of the mission. They trained in mock-ups of the Command Module Columbia and the Lunar Module Eagle, rehearsing launch procedures, docking maneuvers, and the critical lunar landing. Realism was paramount. Section 5, Beyond Apollo, Unveiling the Moon's Secrets Piece by Piece. The Apollo 11 mission marked a turning point in human history, but it was not the end of our lunar explorations. 5 more moon landings followed, each adding to our understanding of Earth's celestial companion. But after Apollo 17 in 1972, the lunar surface remained untouched by human feet for decades. However, the allure of the moon never faded. Today, a renewed interest in lunar exploration is driving new missions and discoveries. NASA's Artemis program aims to land the first woman and the next man on the moon by 2026. This time, the goal is not just to visit, but to establish a sustainable presence. China, too, has emerged as a major player in lunar exploration. Their Chang'e program has achieved significant milestones in recent years. EGAP 3S, Section 6, The Legacy of Apollo 11. The Apollo 11 mission was more than just a monumental achievement in space exploration. It became a symbol of human ingenuity and perseverance. When Neil Armstrong took that historic first step onto the lunar surface, he not only fulfilled a nation's ambitious goal, but also inspired generations around the world to look up and dream big. The success of Apollo 11 demonstrated what humanity could achieve when driven by a collective vision and relentless determination. Gap 1S. The ripples of Apollo 11's impact are still felt today. It spurred an era of technological innovation and international collaboration, laying the groundwork for future space endeavors. The lessons learned from Apollo's triumphs and challenges continue to inform modern space missions. Engineers and scientists often look back to Apollo as a guiding star, reminding them of the potential that lies within human reach. Gap 1S. The spirit of Apollo 11 lives on in today's ambitious projects. NASA's Artemis program, aiming to return humans to the moon and establish a sustainable presence, is a direct descendant of the Apollo legacy. This program seeks not just to explore, but to build a future where space is within humanity's grasp. International efforts like the European Space Agency's lunar projects and China's Chang'e missions also draw inspiration from Apollo, showing that the mission's influence transcends borders. Gap 1S. As we stand on the brink of a new era in space exploration, we remember Apollo 11 not just for its historic firsts, but for igniting a spark that continues to drive us forward. The legacy of Apollo 11 is a testament to what we can achieve when we dare to dream, innovate, and explore the unknown. It serves as a beacon, guiding future generations as they reach for the stars. Section 6. Mysteries of the Far Side. Lunar dichotomy and future exploration. One of the most enduring lunar mysteries is the stark difference between its near and far sides. The near side, the face we see from Earth, is characterized by smooth, dark plains called maria. The far side, in contrast, is heavily cratered and mountainous, with far fewer maria. This striking difference, known as the lunar dichotomy, has puzzled scientists for decades. Several theories attempt to explain this dichotomy. One hypothesis suggests that Earth's gravitational pull might have influenced its volcanic activity. Another theory posits that a large impact on the far side could have thickened its crust. To shed light on this mystery, China launched the Chang'e mission in May 2023. The mission successfully landed in early June 2023, becoming the first to collect samples from this region.